All right, so we're live. Good morning, everybody, or good evening. Welcome to TST meeting, where we're going to discuss design and some requirements for configuration and management subsystem. The idea here is to design it as a separate component in a way that will basically fit the next generation design philosophies. And where it can potentially be used alongside the existing ONOS platform. We also have some guests this morning. We have Larry Peterson, who's the architect for the core CBAB project, and Guru Parulkar, just to share with us some of their thoughts. And Guru, did you want to frame the discussion in some way?
Oh, I think maybe we should let Andrea walk through the presentation quickly, and that is probably a good framing. And then hopefully, we should set aside enough time at the end so we can have a discussion. So that would be my suggestion. If
Sure.
You guys are okay with that?
Sure, we can do that. Here, Andrea, I'm going to make you a presenter.
Thanks for that. Okay. Can I share my screen? Okay. Can you guys see my screen? No?
Not yet.
Not yet.
Yes.
There we go. So, it seems like you bounced the presentation to me.
Actually, I can't see the presentation unless I'm seeing.
So I'll make you presenter again, Andrea. It bounced back to me.
Just give me a second, guys.
Alternatively, if you want, you can just share the link to the presentation on the chat, and I can put it up if you want.
Yeah, let's do that. Unfortunately, I don't know why it's not working on mine.
No worries.
It always works.
I'm just waiting for your link.
Yeah, coming. I need to share it to everybody because it's really not sure. What the hell is happening? Okay. Chat here. Okay.
There it is.
Can you share it, Tom?
Yeah, but you need to. Can you make it public, please? Public, because I got access denied. I'm not doing it from my laptop. I'm doing it from the conference room.
Oh yes. Done. Should be able to see it.
Yeah. All right. There we go. I just want to make sure I'm presenting it. Okay. There we go. Share it. Okay. So yeah, I assume everybody can see it, right?
Thanks.
Okay. Go for it.
Thanks. Okay, so the idea is that we have been working on discussing and thinking about configuration and management in the past some time, but with looking at all the reference designs that ONF has and other documents and other talks that we heard from, for example, at ONF Connect, I felt with the help of Guru and also in the context of NG ONOS and in the future for ONF Future to really need to do a clean slate of software-defined configuration and management. So, would you like to? So the idea is that there was a very interesting talk back in 2017 from Google, which outlined a vision which they implemented, which they called zero-touch networking and SDN. So the idea is that Google found that the network operations came originally with a trade-off between scale, reliability, and efficiency, and one could only pick any of the two. Meaning that you could have a scalable network that can accommodate more sites, can go for more capacity, more bandwidth, and it was reliable because it was like but it was over provisioned, so it did not have efficiency. You could have scale and efficiency, but not reliability, and that was not good enough from Google's perspective. So they came up with this vision that they called zero-touch networking. That is based on intent-driven operations that can achieve reliability, efficiency, and scale, and accommodates the evolution of the network, which happens if you read Google's papers and information and receive information from them. It happens daily, even more times in a day. They introduce new services, new hardware, new functionality. So they built a system which was capable of automating all the operations. And this slide is from Google. I just changed the fonts a little bit, but they made a system that automated all the operations, that required less steps from a human operator, because after the instantiation of a high level, call it intent, call it policy, the human would detract itself from the operations. And then the changes to the network would go down and be applied to individual network elements by being fully declarative, meaning that this is the change that it needs to happen in these set of elements for the configuration of that device. Obviously having a capability of being vendor neutral, in the sense that the configuration was not specifically tied to a manufacturer, but it was modeled against a device-centric model, namely OpenConfig, which they open source. And the configuration was derived by the network infrastructure model and the high-level requirement of the operator. Those network changes also immediately halted and rolled back if the network displays unintended behavior. And this is fundamental because also in past work that people have done around management and configuration, there was just one snapshot of the configuration. This is the state that is at the moment. But if you make any changes to this, you cannot roll back because you don't have that information. And also, somewhat very importantly, there was some checks around the configuration that you were doing against the network in order for it not to violate any network policies. Another two fundamental elements that are important for this effort that we will start is velocity and availability. Availability means that you're keeping your network and you're delivering the service you're providing. You promise a very high of time. And initially, Google had the network available for 99% of the time. But then through this automation that they put in place, they were capable of bringing it to 99.99%. So 4 nines of availability. The other important element is the velocity, and that's what I referenced before when I mentioned the speed of update and upgrade and evolution of the network. So every day there is new elements in the network. So automation enables easier testing, visibility inside what's happening in the network, expansion of the network, and iteration of software components and hardware components. And a very important phrase that I caught from a meme at ON.F Connect keynote, it was that the SDN balances the velocity and availability while also providing that reliability, scale, and efficiency that we were talking about before. You can achieve it easily through SDN. Also, something that I wanted to point out to probably set the stage on why are we doing this and why are we rethinking about configuration and management is because by reading all the resources and especially this one, which I encourage everybody to take a look at, Google said that 70% of network failures happen during management operations, like any type of management operation, like devices related or software element related, anything caused 70% of their network failures. So they said we have to do a better job with that. And so for that, they started looking at this their own way, and they developed a system which we will talk about later, and which I think is also a perfect example of what we would like to build. So always staying in the vision of the, Tom, can go next slide, please?
Yep. Oh, sorry.
So just to set the stage, what are some example use cases that we would like to embrace in this configuration and management effort, like multi-domain connectivity across elements that are not like OpenFlow based or P4 runtime based, but avoid network management and control errors like downtime, failures, have ease of development and integration for new services, capability of insertion new hardware and software, scaling the network in size and capacity, also having the capability of like decommissioning the device while storing their configuration and putting in place new devices which have the same configuration, dealing with failures, having the capability of doing root cause analysis. This is key to having such insight as like Google does. Monitoring the SLAs, the network state, but also debugging performance issues of the network itself. So to really achieve zero-touch networking, there is a need to a seamless interplay of control and configuration management to happen, because the high-level network-centric policies are always a combination of control and config. There is no way you can achieve one without the other. And we have, as ON.F, we have done a very good job in control, but we lacked a bit in configuration and management. And thus, this is why we are targeting a new iteration of this implementation. So let's give an example, like of an end-to-end control and management collaboration to achieve a goal. That's like, for control, you need upgrading a switch. You need to drain the traffic from the switch, divert into other path. Then the control goes to the config and says the switch is ready for the upgrade. Then the configuration powers it down, updates it, reboots it, provisions the ports, and then tells the control the switch is back up, move traffic, and then the control moves the traffic over again. So the idea is that we can have this type of interplay within ON.F projects, and is in the good control that we have, but a good config management also. These are kind of high-level business-oriented topics. The config and management operations automated, reduce the OPEX, and allow a DevOps team to introduce new innovation with more velocity and reduce the CapEx for the use of simpler boxes or merchant silicon and open source software and hardware. So there are a few challenges that we face. The fact is that there is no single platform that comes close to achieving an interplay between the configuration and management. ONOS emphasizes the control, ODL the config, and the provisioning. The single platform is not really there, and at the moment there are not that many devices that support at the same time in a proper way control configuration and operation interfaces, and that is getting fixed by Stratum within ONF. And we also have some defined use case that require a common platform such as ONOS to be integrated in, such as the FCAPs with SIBA. At the moment, we have just seen this interplay between configuration and management done at a scale, at a proper scale, within this the Google approach that is taken. The problem it's proprietary, and we don't have any insight in how that is done. So I've mentioned it a little bit, but let me now go into details of what this Google architecture for configuration and management is. The idea is that Google has built this system which operators define what they want to change in the network in a workflow graph. Then they submit this workflow graph into an intent API. That intent API leverages three models, mainly the topology and the network model, and the system also uses the device-centric models. The configuration that is sent to the intent API and managed by the configuration manager is stored as text in a configuration database. The database has versioning and configuration delta calculation with rollback capabilities, and the database is also built for durability and high availability. At least this is what I understood from studying the Google work. And then there is a configuration generation service that basically maps a high-level device agnostic configuration into network element specific capabilities. One thing that is interesting is that they never say that this is just purely devices. It might be also a subcontroller or another piece of software that works for something else. They have open source.
Andrea, if I could stop you. So do people understand what this really configured generation services are? I'm really not, I don't have a good understanding of what goes inside, I mean, as an input and what comes out as an output. But if rest of you understand it, maybe offline somebody can help me explain this. But for now, I just want to say that I don't understand what exactly does this do.
What do you mean? What does?
So what is the input to this config generation service?
Oh, I don't know at the detail level, sorry. Okay, I just didn't understand.
Yeah, I mean, I was trying to understand what will be the input to it and what is the output to it. What is the form of the output? I mean, even at the conceptual level, if you understand what is the input, what is the output, and what it stores inside.
So the way I have seen it is that, for example, an operation like reboot of the device comes in, and to do that there is a set of definite configuration that needs to happen for that device to be capable of shutting down properly and then booting up properly, okay? Even for a single device. So what happens is that it comes in as this operation defined in some form of model probably, and then what comes out is a set of let's say open config blobs of text that gets sent out to the device and the device understands. That is kind of how I see it.
So basically, they've modeled all their generic commands that they ever expect to run from the intent or policy, and they've mapped those either to OpenConfig or other scripts, whatever, to apply to specific devices.
I wouldn't say all of them, but at least from my understanding, there is a good set of high-level elements that they have mapped to device-specific, and you're correct. The device model that they use is OpenConfig. That's the device model. They have not open sourced the network model, which is that component over there. That is not open sourced. And they have not open sourced any of the other components, as far as we know.
So I guess what I'm trying to understand is, so when you look at in the config generation service, that is where you store device models and all of that. So typically, so far, whatever work we have done in the context of ONOS for config, there's a concept of a config store where you're storing all the models and operations, and then maybe high-level operations comes, and then you generate, as David said, you said, a script, and that is the script you pass it on through OpenConfig and operate on the devices. So is the majority of the functionality of the config subsystem that at least we have thought of in the context of ONOS, is that part of the config generation service, or am I or it is something else and I don't understand it?
The store is a different piece than the config generation service. The store is that database of configuration, which purely, in my view of this, saves the configuration.
But doesn't for the config generation service to generate that script that you're talking about, doesn't it need to have something stored somewhere that it is accessing in order to generate that script?
Yes.
And what is that it is accessing? Isn't that accessing models and all of that in order to generate the script?
It's at least from my understanding, it's accessing configuration, in this sense, high-level configuration, and then creating device-specific model-based information. I mean, you have to know what models supports a certain device in order to be capable of generating the payload. So the config generation service is generating the payload based on the device model and storing it in the.
So the thing is, semantically though, we have to know it's analogous to our intents, right?
Yes.
I don't know the details, but semantically, there has to be an understanding on what it takes to take a high-level intent and how to boil it down into individual steps. What things need to be done to each device in order to accomplish that intent. Yes, it requires that the system is aware of the current state of the devices and not its full state, at least with the state with respect to the relevant pieces. For example, I don't think it's necessary that the configuration manager, at least in this particular case, is aware of all the models that the device has. It needs to know about those parts of model that need to be manipulated, and so that it can manipulate them consistently, and so that it knows which deltas to apply. But it's going to be highly specific to certain semantics of the use case. You know, so for example, be able to make sure that the certificates are in the right place, be able to know that the reboot sequence is in the right place, be able to know that the interfaces in the right state are in the right state, and things like that. But it may not, for example, care about what the power over Ethernet settings are, just as an example, right? So.
Right. One thing I think Google's acknowledged too is there's a key aspect of here, not knowing what changes need to happen to a device, but any sequencing between inter-device changes or dependencies.
Correct.
As well.
Correct. And
yeah, more.
Yeah. And also need One thing I know for sure what Google does is it doesn't consider necessarily just the state of the devices themselves, but also make sure that certain network level policies are not violated. So it runs it through a kind of a sanity checker to make sure that a part of the operation doesn't dissemble the network. So again, rather than speculating, I think it would be, if you want to learn more, or if you want to mimic the Google approach more, maybe we need to have another round of discussions with Google on this particular thing.
Yeah, I think that was very, and I really much like, and I don't know if it shows later in the presentation, but in a previous iteration of what I had later, really that blue component, in my mind, looks a lot like what, at least conceptually, the intent compiler was.
Right. Yeah.
So it took like a high-level intent and it produced flow rules. In our case, it would take a high-level policy and produce open config.
Correct. And it should be noted that the intent compilers are basically, they have semantics associated with them. They know what it is that they're trying to accomplish, and then they know roughly how they're going to accomplish it in terms of what operations. In this case, it would be in terms of what models.
Yeah. Okay, thanks.
Okay, that's enough for now. Okay, good. I mean, thank you. Appreciate it. Yeah.
Ready for next slide, or?
No. Go to next. So the idea is that, but then by looking at what has been done and what the state of ONF projects are, is that any ONF reference design can benefit in different shapes and forms of a proper configuration and management subsystem, because ONOS doesn't have it, but all the reference design have some type of configuration and management. The CIBA has AT&T specific FCAPs, and there is a whole set of Volta elements to manage. Then there is Trellis, which does use some specific elements of netconf, maybe using ONOS, maybe not. There's really not that much insight in there. ODTN has tried an approach with an ODTL style config and management that hasn't really gone that well, because it leverages existing dynamic configuration subsystem, which we know has a huge gaps in pieces here and there. And Uban does support, Stratum supports the control config and operations, and ONOS is implementing them in a way which is not general, which leveraging some behaviors and some elements which are, for example, do not support rollback, the few things that need to happen over there. So there's both an opportunity and a challenge to create a solution around open APIs, standard models based on Stratum, ONOS, and reference designs, and create a subsystem that can be the base for also NG ONOS configuration. So the idea is that if we take Trellis as an example reference design, we can put Stratum on the devices to support P4 runtime, OpenConfig, GNMI, and GNOI. ONOS needs to support those interfaces, which already does as a protocol level, but we need to add the configuration and management on the side and find some ways for ONOS to control that piece and find the control and configuration elements working together to achieve a full set of operations on Trellis with the apps, with some apps. So the proposed architecture I have kind of looks like what Google is doing. So we base ourselves on the existing ONOS, but the key component is that we build this new elements which are not the gray encompassed boxes, but can be reused as a self-contained subsystem for next generation ONOS. So The idea is that at the moment, ONOS uses its own topology model, which is not by any means standard of sorts. And for this configuration subsystem to happen, we kind of need a standard topology model. So we would have that component that interfaces with the existing ONOS topology manager. Then we will have this configuration manager, which handles all the configuration for the devices. As I said, has this config generation service, which has an intent-like compilation for configuration-related elements. Has a store which saves information inside it in text and not in like Java objects or other types of objects, but instead the text-based approach is much better. We have seen at least so far. And then we have a configure operation command piece that receives the configuration from the configuration manager and uses the existing protocol subsystem in ONOS to push this to the devices. So, Tom, can you go to the next slide?
Are you tying this directly to only OpenConfig, or I'm sorry, if you go back to the slide, you have it going down towards ONOS to OpenConfig, but it could go to multiple different southbounds.
No,
for different one, different controllers could be controlling different devices. Two, one could be using OpenConfig or GNMI. One could be using another protocol.
No, no, definitely this is not tied to any specific protocol. I mean, or model for that reason. Obviously, we would start with OpenConfig because that is a well-known standard that is already used in 2 of our reference designs.
Right.
ODM being one and UPAN being the other one. But there is nothing here that ties the architecture to OpenConfig models.
Right. So the model that the configuration manager operates on is, call it a generic tuple model, if you will, whatever you want to call it. And then there's a translation from, like a compiler translation, if you will, from the generic tuples to model specific, whether that's OpenConfig or something else.
Well, yeah, the thing that executes the intent has to know the semantics of the model, right? It's not going to be, in order to get certain thing done, we need to know how to do it, how to get it done in terms of a specific model. And so there has to be knowledge of the model semantics at that level. But at a level of maintaining the configurations and be able to extract them, compare them mechanically, that can be completely model independent, right?
Yes.
To get through the proposed text representation.
So that would tell me that this will only work for models that share semantics. In other words, only OpenConfig.
Oh, or you would have to have a different compiler to get something done, right? I mean, that's the whole value of the models is and standards is that they don't mean anything unless they're ubiquitous, right? Or reasonably so.
So
even if you have separate compilers, there's chances that intents would have to cross those compiler boundaries.
Exactly.
And so
yes.
You have to deal.
Quick question though, Andrea. My suggestion would be: so is this implying that we would use the existing southbound of ONOS?
That was my understanding, at least for a current generation of ONOS, we could reuse what we have in terms of the netconf controller, the GNMI controller, or any given protocol controller that might arise in the future. And that is because there's a lot of code that's already being done for establishing the channel and bringing up the device and making sure the device is reachable and all of that. That at least for a first iteration, I didn't want to redo the whole thing in there, but instead, since though that is just a pipe, basically, reuse what is existing. That would mean
my suggestion would be to, even though that's what it may end up being under the hood, but we need to structure it, in my view, so that the piece that's kind of in that white background is completely self-contained in a sense that it at least thinks that it is its own southbound. I don't want to deform the architecture of the new piece with constraints of today's architecture. So my suggestion would be to treat it as a completely separate column that does its own thing, and then just loosely integrate it with the existing ONOS. That would be my suggestion.
So if you can you hold that thought for a minute?
Yeah, I definitely can.
Okay. Let me go through slides 20, 21, and 22, and on 22 there's a little bit of thought on that.
Okay.
So as I was saying, we need a network topology model to properly expose the topology that it's currently present, because at the moment there is the ONOS topology model, but that is not a standard, and that is not well known to other elements that will in turn use this component configuration subsystem. And the network topology component will also do a translation to and from the ONOS topology with a subsystem in itself to integrate it with the existing ONOS, but leaving the network topology component to be separated. It will need to store the topology changes according to the model and update the controller, the remaining controller topology according to the configuration changes. When according to your point, Tom, when I mention ONOS, there is just a wrapper that binds it to the existing ONOS. And since this subsystem, I envision it to be configuration event driven, those components that tie it to the existing ONOS would only be wrappers that are not in the subsystem per se, but listen to events that are generated by this configuration subsystem and do the translation. That's how I would.
Okay, quick question about the topology model prescribed by TAPI. Is that largely a read model, or is there actually some write aspect to it as well? Because in traditional sense, with ONOS, topology model is effectively just a network graph, right? Very flat network graph.
Yeah.
It can consist of islands, and it's primarily the authority for what that looks like is with the environment.
Mm-hmm.
We observe the environment, and then we portray the environment using this graph. Is TAPI operating in a similar way, just in terms of structured Yang model, or is there actually some sort of a means to define networks and to kind of push what the graph looks like from the orchestrator?
No, at least from the perspective that and to the level that we use TAPI in ODTN, we have used it as a well-known abstraction of the ONOS topology graph. Okay. So that is how we have used it. There might be options inside TAPI to do a push of the topology. Honestly, I have to say I don't know. Okay. If that is of interest, we can also reach out to Karthik.
No, I just wanted to make sure that, pardon my ignorance here, but I just want to make sure that the use model was somewhat compatible. That's all. But yeah, not so much tangent, so this is good.
It is what in the current ONOS and current ODTN, what we are doing is that we're taking the topology events from ONOS and we're pushing them to we're translating them to TAPI and saving them. And if you ask about the TAPI topology through RESTconf, you're gonna get that topology.
Okay.
So, and I put TAPI there just as a peace of mind, just as an example. I don't know if that is the one we're going with. That is the one I know, and is well also in the industry. There's a lot of work around it, but maybe somewhat more related to the optical space. And we would have to see if it encompasses other elements too. I know it does. I don't know how well it does it. So it might be also something else.
Okay, thank you.
So then a big component is that the configuration store, which thanks to previous studies that can be found in the document over there, and thanks to the effort of Utah and others that have worked on it, and also Jordan has given some thoughts to it. The idea is that we want a log-based store to enable batch operations, be capable of dealing with the configuration deltas, storing the configuration as text in a format that is much easier to serialize and deserialize and work with than Java objects, because that is also a more compact store and works better with multi-versioning, which a Java-based store does not really do well. Another key component is looking into the primitives, meaning an easy look into what we want to store in there. So then other two components is the configuration cache and store. So in this particular case, if we're tying it to the existing ONOS, the green component would be living inside ONOS itself and would receive the configuration, the operation, and the subject through gRPC from the configuration manager and translate it to the existing southbound ONOS components.
My suggestion would be to completely leave existing ONOS out of this picture, for at least for the purpose of this discussion. I think we shouldn't paint it at all.
Oh, yeah, for sure. My thought in here was that this is just a translation level. There is really no logic in there. So it can be replicated, as David was saying, also for other controllers. So through gRPC, you're handing it some element, and that it's taking it and dealing with it on the southbound. That green piece over there is what, in my mind, just deals with any existing southbound way of delivering the configuration.
Yeah, so one thing I'm a little bit, I guess what I envision that what we would do, at least initially, would be to narrow the scope of implementation to purely deal with GNMI and GNOI, and as channels for exercising control and operational aspects. Leave netcons completely out of it, because what that will do is it will, well, first of all, it will simplify the implementation. It will also give us off-the-shelf transactionality with respect to batches of operations on a single device.
Mm-hmm.
And also, it might give us, if we were to expose our own, so the intent, the northbound operations as GNMI as well, just possibly different models, right? We would expose transactional semantics upwards as well. And so then all we need to do within is just make sure that we implement the transactionality across devices, across operations.
Right, but now you've got the problem that you've built in semantics that are definitely in GNMI, GNOI, but may or may not be in other protocols that we have to support down the line.
So the thing is,
right?
So the question is right. Well, the thing is, one could argue that the old protocols are deficient in certain ways, and this is where GNMI, with its crispness and sort of minimal approach and support for transactionality, has a significant advantage. And so it might make it a good northbound protocol for the controller itself. Obviously, on a south, we would architect it so that there is a separation. There is some assumption on what the capabilities of the southbound protocols are to some level, but we're not necessarily tied to it. So clearly, the idea would be that we eventually support Netcon from a southbound as well.
Right, right. But you've bound in transactionality, which most protocols don't support, right?
Well, and this is where a lot of the savings on scope would come in, because clearly, if the transactionality is not offered by the protocol, then it has to be built in on the southbound itself, right, in order to accomplish it. For example, SNMP, right? So that's a big fat piece of software that we don't have to write.
So agreed, or it never gets written, more likely. So the question that comes to mind: who other than Google is going to care about GNMI, GNY, and OpenConfig in the next year and a half or whatever to deployment?
Anybody who's behind Stratum, right?
Are they going to be deploying, or is anybody going to be deploying devices in production that support GNMI, GNY within the next year, other than Google?
I think it would be interesting to ask. So besides Stratum, we should be, yes, I think it's a valid question, David, and we should be asking in these different IDs, because end of the day, those IDs are also important. And so we should try to see whether some of this will get a part of the IDs that ONS has. So that is some exploration that or thing we should do and see. But I agree with Thomas that if there is too much that we take on, then again, we may not be able to make as much progress. And if we tie too much of this to the legacy, then again, we're not be able to make as much progress on the capabilities. But at the same time, it has to be relevant to ONF RDs. If it is not relevant to ONF RDs, then we have a serious problem. Maybe the priority will not be the larger industry, what they are doing and what they will adopt, but at least it has to be relevant to the ONF RDs.
Yeah, I agree with what you said, and I agree with Thomas what said as well. My real concern is, are we limiting future expandability based on the technology choices and how high up the stack we take those technology choices? Because we narrow our scope, which gives us a faster delivery time, do we end up inadvertently or advertently putting in aspects of that technology that we chose into the semantics of the whole application that make it hard to extend it to things that don't follow those semantics later on? That's my whole concern. By picking a single semantic, we get speed, but often because we're doing it fast, we bake things in that we may regret later.
It's a fair point.
David, one thing to answer your question, there are some vendors that have shipped products into production that are using GNMI as an option. Typically, they also pair that support with Netcom PressCom, either one or both. But there are definitely others that are using GNMI in the context of more traditional networking today.
Yeah, but are people using them in production, or device companies are shipping production? I guess is a difference, right? Are the carriers using it? Is really the question.
That's a good question. I don't have an answer for you.
I would imagine not, because I mean, what's the state of the, where are controllers that use GNMI, right? I mean, there's ample controllers or network management stations that know how to use Netcom, but very few. I think almost the only one really that does GNMI at this point in time, right? And then who has in house?
I think there are commercial controllers that do support GNMI, but I'm not at liberty to discuss the vendors.
I could tell you, but I'd have to kill you. All right.
I know Cisco is working on stuff too, right? I mean, but anyway, I just don't know where it is in terms of production readiness.
Yep. Okay.
Okay. So.
Yeah. Some of my thoughts and some of the key questions regarding this specific discussion. I think there are means of achieving support for transactionality through GNOI, while at the same time leaving the door open for netconf-based southbound, which, at least from my exploratory work and reading the RD specs, is still the key for 3 out of 4.
Yeah. So can I maybe just bring things up a little bit at a higher level, just to make sure that before the meeting runs out, if these pose some questions. It would be good to identify at least one, but ideally 2 or 3 kind of top-level use cases that you would like to demonstrate. Basically, kind of 3, let's say like 2 or 3 different intents that we would like to demonstrate using this solution. You know, for example, like a software upgrade on a switch might be one use case. Might be bring up of a new switch would be another one, or decommission of an old one, or something like that. Right? We would need to pick and choose some high-level use cases.
Mm-hmm.
To do. I mean, we could do smaller things like configuring set of ports for certain stuff as well. But it would be good to have a kind of a vet the validity of those use cases with some of the telecom providers that we have, so that we could have something to aim for, right?
So Thomas, yes, so I somehow thought that because Trellis in some sense is a part of almost most of our RDs, and it will be part of the new COMAC as well. So if we were to pick these use cases, those are in the context of Trellis, and also because Trellis uses switches that will most likely will have Stratum, and we can put together a Trellis fabric using Stratum much sooner than anything else. So would we pick use cases in that context first and then generalize them?
That sounds good to me. But if you could kind of identify on a priority of these use cases and have a buy-in from the service providers, that would be great. If they were aware of what those were, and or better yet, if they had input on what they were, that would be ideal. And yeah, I agree that if you can combine it with Trellis, that would be best, because we already have kind of the control aspects of that done.
And I might have a few from ODTN, which are both which are related to optical elements.
Okay, so maybe what we ought to do is, you know, we have the Nextgen ONOS document started. Maybe in a section of the Nextgen ONOS, if you could kind of identify config management use cases.
Thomas, I would not put this so-called this Nextgen config and management completely under the Nextgen ONOS. I would create this as a separate thing. This can be tied to current ONOS. It can be tied to Nextgen ONOS. So I would prefer this to be living outside both of the current thing, and it can be tied to either. I really think this is such a high priority right now that I don't want it to be lumped inside the larger Nextgen ONOS. And I think you and I have talked about that. So maybe this is just a tactical issue in terms of whether to put that in that document or create a separate document.
Sure. I mean, I can create a separate document, but I would just like to create a separate or a document where we can start putting some of these thoughts down for other people to be able to comment on or contribute to, that we can, you know, we can consolidate this work and start moving forward. So that's fine. I'm not opposed to starting a document for this.
Okay. Yes, I think if generally people agree with that, this presentation with emphasis on some use cases can be turned into a document that describes this and motivates this. yeah, I think that makes a lot of sense. And then have an explicit thing that how it interfaces with current ONOS and how it interfaces with the Nextgen ONOS, or how we want to do this. So Thomas, I'm 100% agreeing with you that we should do this in such a way that it will nicely fit into Nextgen ONOS, but it should also work with the current ONOS as well.
Sounds fair. Yeah, and so speaking, one of the, I guess that was not necessarily highlighted here, and I'm bringing some of the Nextgen ONOS rationale into this picture. It's important to me that we kind of shed the liability of using the current ONOS Yang tools, which are really Java specific. It's 100,000 plus lines of code that we've lost the original maintainer for. It serializes stuff only to JSON and XML. It doesn't really work with GNMI. And so I would rather just completely sideline those sets of tools and use off-the-shelf tools like YGOT, for example, so that we can take the Yang models, compile them into the stubs for to protobufs, and from the protobufs, then they can be compiled into stubs for various languages, including Java. And so I would prefer if you took that approach. Also,
yeah, I fully agree, Tom. And I think a key lesson here was that the store is also text-based. It's because it's much easier. So I would agree with avoiding the baggage of existing tools that we have.
Yep, yep. And similarly, I really would like us to explore the viability of using GNMI and GNOI as the northbound API for the controller, at least for this config and management section of the controller, because in certain respect, the controller itself is just a sort of management proxy, right, for a set of for kind of a virtualizer for an environment. And if the semantics of the GNMI are good enough to operate on elements in transactional manner, we should try to see if they're also good enough for the controller itself. And this
interesting. So maybe I didn't just to be sure, Thomas, I want to understand. So what you're saying is that the northbound also is GNMI and GNOI for config and management?
Correct.
Is that what you said?
Correct. Yes.
And the southbound is also, and southbound is also, at least this is one of the choices, and then northbound, yes, we make the choice that this is GNMI. Oh, interesting. And again, I don't understand it enough, but does it have that richness that it can be that protocol both at the northbound?
Well, the thing is, it has the simplicity. It's basically GNMI. It really is extremely condensed. It's effectively give me your capabilities is one operation. There is a get and set, and there's a subscribe, and the subscribe effectively gives you a stream of notifications. And you can ask for subscribe as with different semantics, either as a continuous stream or as a polling for telemetry data, or as a once sort of a fetch. It's basically just a streamed fetch, so that it's like a streaming iterator effectively for the configuration. It scales well for large volumes of configuration data, and it has a transactionality built into it by the standard of it, and it's secure. So it's very narrow, very simple, it's capable of dealing effectively with any Yang prescribed model. And as a matter of fact, it doesn't even have to be, the model doesn't have to be prescribed by Yang. As long as it can be compiled into protobus, it's fine. And so I think because it's so simple and elegant, and it's elastic to accommodate any model, and there is tooling for it, it might be a nice kind of ubiquitous way for other applications to deal with the controller as they deal with other elements.
Okay, I mean, I guess everything you say makes it sound very appealing, and simplicity is always best, as long as it is not so simple that it lets you not do certain things that you naturally want to do at that level of abstraction or that level. So, but I don't have enough understanding, but let's make sure that, it is simple is good, but it's not so simple that it's a barrier of some type.
Right, which is why I framed it as we should explore the viability of it being used as an
Okay, okay, sounds good.
So as the action items, I think at least personally, I will take on putting down some like intents, what we called in this presentation, like the upgrade on the switch, the related to trellis, and maybe a few with ODTN. But I think this requires at least some more architectural thought, or at least to dive into the architecture, because the picture I had was very much high level.
Yep. Okay, so that sounds good. So will you create a document, or do you want me to do that?
I can start one.
Okay.
So I guess if Larry's still there, I'm kind of curious if, and people have time, at least I have some time to hear, Larry describe, you know, in the context of SIBA, we are doing all this FCAP functionality in NEM, and we are almost bypassing ONOS. And so I'm curious to know if ONOS had this config and management capability as we are envisioning here, how would SIBA take advantage of it, or how would the SIBA FCAPs would take advantage of it?
Well, I don't have an easy answer. The strange, first of all, Volta has a fair amount of responsibility here independent of ONOS. So that's really where a lot of the control and config management of the OLTs is. The second thing is, most of what NIM is doing is at the service level. Not at 10,000 feet, it's a very similar story. But a lot of what NIM is doing is at the service level, not the price level. Now, the fact that AT&T turns around and turns this set of services into a pseudo device is a legacy thing, and the fact that we call that FCAPS is a legacy thing.
No, but so tell me something. I mean, let's say, so in SIBA with FCAPS, are you worrying about devices coming up, taken down for maintenance?
Well, I mean, in principle, I'm sure that all the cases have not been covered, but yeah, ONUs and OLTs coming up and down and being available, and what that does to the workflow. But it's not 100% complete. It's all within scope, but it's not all. We're not zero touch yet in that respect.
And does configuration of OLT, and even in the SIBA, there are switches, right? Maybe they are not necessarily, but the way Saurav described it is the simplest fabric. And so you do have an open flow switch and all of that. So how is the configuration and all of that handled for that switch? Is that part of the FCAPS and the flow, or that is not part of the flow?
Well, so the first thing I would do is I would just not use the word FCAPS. I think that was a way of AT&T expressing there's some pieces missing. But the way this all ends up, in my view, is a traditional FCAPS. Whether someone wants to wrap it in a way that pretends it's FCAPS or not is another issue. But to that specific point, NEM deals with ONOS and would deal with the configuration management aspects of ONOS if it was available, and not directly with the devices. So in that, you know, to the extent ONOS manages the switches, config manages the switches as well as control, NEM would take advantage of that. Now, do you end up with multiple? Do you end up with multiple levels of declarative intent? Probably. That would be an interesting case to look at. And NIM is perfectly happy abstracting away the devices below it and letting ONOS deal with that, for example. So NIM doesn't have a particularly strong notion of network topology, for example. It has a strong notion of this service depends on that service, and I might have a concatenation of those that give me a data path. But it is completely abstracted away the topology of the network that's underneath it. So it doesn't have the visibility in the switching fabric side into the devices. There would be Yeah, I need to think about this some more, because certainly there are similar high-level designs going on here, but the fact that you're working at device level versus the service level puts the hard parts of the problem in different corners of that space.
And that is perfectly okay if we chose
okay
the SIBA architecture.
It may make no sense whatsoever to try to unify those. Maybe there are some small opportunities to be consistent. I don't know.
Oh, I was not suggesting unification. I was just saying that making sure that the division of responsibility is good. And so actually, if you can take care of the device and network level configuration and management at the ONOS level, both for the OLT side as well as on the switch side, and then yes, NEM is of course interfacing to their OSS DSS system, but also managing the services, then that division of responsibility is perfect. But right now, because all of that it appears is handled by NEM and ONOS is bypassed, I was wondering whether NEM is doing more than it needs to do if at the ONOS level we had the right config and management capabilities.
So in some sense, that's what you just said is correct, but that's because A, the switching fabric is trivial. B, Volta hides the complexity of the PON. And so there's a ton of configuration that goes on there, but that's all Volta's business. And so you could argue it's already addressed that problem in the PON case.
So that would be interesting. So does, I mean, again, I wish I knew Volta more, and maybe David knows this more, that does Volta have this kind of config and management capability that we're describing in the context of ONOS already for all the OLT devices and ONU devices? So did we lose David? Maybe we lost David. Okay. Maybe somebody.
No, we may have lost.
Okay. Yeah, I think these people left. Okay. So we need to figure that out, because if Volta is already doing all of this for the OLT, then in the SIBA context, the requirement may be very similar to Trellis, and that is perfectly okay. Then we are only worrying about managing switch fabric, config, and management, and that simplifies our life.
Yeah, I mean, if you think about the PON case, just back to the Volta, what you said I think is maybe right, but the PON case, it's a very simple topology. It's entirely the PON fan out, and so it's a very stylized problem. Anyway, I think
I know.
Might be the right breakdown.
Okay. But I'll be still interested in understanding how Volta is doing this, and so that would be a good thing to understand for us, and maybe we can learn something from that.
Yeah.
Okay, I guess I'm done. I don't know, Thomas, you have any more conversations or topics?
I think we need to probably wrap up. So I think this is a good initial salvo here. Thanks, Andrea, for putting the presentation together. So let me know when you start the document for the use cases or the high-level intents, and we
Absolutely.
can. You should probably vet it with service providers after at least the initial draft.
Yeah.
We can start additional discussions on this.
Definitely.
Anyway, thank you, everybody. We'll hold the next GST meeting in 2 weeks is scheduled, but if anybody has any other topics, urgent topics, we can always schedule one on demand. So please let us know. Thanks, everybody. Bye-bye.
Thanks.
Bye.
Bye-bye.
Bye. Bye.